Very good afternoon to all. My name is Karthikeyan, Professor in AI&DS Department, Arunai Engineering College, Tamil Nadu in India. First of all, I would like to thank our college principal and register and my department head. And also I would like to thank the principals of STEKOM University and various staff members and various department of STEKOM University. First, today I am going to discuss about the distributed computing in social uses. So first of all, before I'm going to explain this topic, first, did you know about what is distributed computing? This distributed computing is nothing but it consists of multiple software and components that are multiple computers but run in single system. That is known as distributed computing. So this is the black diagram of distributed system. Here the centralized computer system, it will be connected to various parts of the computer system and coordinate activities and sharing the resources to computer system. In social uses in distributed computing, it can having various impact. The first one is social network analysis. The second one is crowdsourcing and collaborative project. And third one, disaster response and crisis management. And fourth one, healthcare and medical research. And fifth one, blockchain and decentralized application. And the next one, educational platforms. And next one, gaming and virtual world. And last one, social impact projects. The first we discuss about the social network analysis. This social network analysis, it has been following the 5 key points. The first one, data distribution. Second one, parallel processing. Third one, load balancing. Fourth one, data synchronization. And fifth one, scalability. So these are the manipulating the social network analysis. Here the first data distribution is nothing but this is the user data and interactions are distributed across in the multiple servers and it preventing any single point of failure and improving the system reliability. That is known as data distribution. And second one is parallel processing. This parallel processing is nothing but the task like user feed updates and searching queries and recommendation algorithms are processed in parallel across in different machines and speeding up response time and managing large volumes of data efficiency. And the third one is load balancing. This load balancing is nothing but it is distributed incoming requests across in the multiple servers to ensuring that no single server becomes overwhelmed. That is load balancing. And next one is data synchronization. This data synchronization is nothing but the data from various servers is synchronized to maintaining consistency and accuracy across the network and ensuring the users see up-to-date information regardless of which server they interact with. This is the data synchronization. And last key point is scalability. Scalability is nothing but this is the network grows and additional servers can be added to handling the increasing data and increasing the loads and the user activity and it will be allowing system to scale dynamically. This is the scalability for all the key points. It will be enables and social networks to manage and to deliver a seamless user experience even as they grow and evolve. And the next one, crowdsourcing and collaborative project. This crowdsourcing involves to gathering input, idea, and services from large group of people. It has typically from an online community. The distributed computing to enhances crowdsourcing in several ways. The first one is data processing and analysis, and second one task distribution, and third one scalability, and collaborative projects. It will be encompassing the various way. The first one shared resources, second one version control and synchronization, and third one data storage and read write, and last one real time collaboration. Here the crowdsourcing in several ways the following the distributed computing. Here the first one is data processing and analysis. The crowdsourcing platform can be used the distributed computing to aggregate and analyze the data collected from large number of contributors. For instance, the platforms like Amazon Mechanical Turk, it uses distributed system to managing and process micro tasks performed by global crowd. And second, the task distribution is nothing but it can break down complex tasks into smaller manageable unit and distribute this task among the numerous participants. This is used to scenario like image labeling, where a task might be divided and sent to many contributions for faster completion. And the third one, scalability. The crowdsourcing scalability is as the number of contributors grows, the distributed system can scale to handling the increasing loading. This is crucial for handling the large volumes of the data task efficiency without bottlenecks. And the next, collaborative projects. These collaborative projects it involving the multiple individual organization working together towards a common goal, often using shared computing resources. This distributed computing supporting this project in various ways. The first one, shared resources. Second one, version control and synchronization, and third one, data storage and reader, and next one, real-time collaboration. The first way, sharing the resources. This sharing resources distributed computing allowing the collaborators to sharing the computational resources such as power and storage across the different location. And the second one is version control and synchronization. This version control and synchronization, it collaborative project often requires simultaneously working on shared files or code. That is known as version control and synchronization. And third one, data storage and retrieval. This data storage and retrieval distributed systems to ensure that the data from collaborative project is stored across the multiple server or node, and it will be providing the redundancy and the reliability. So this is going to be help in managing large number of data sets, and it will ensuring the data is accessible to all collaborators. And the next one is real-time collaboration. This real-time collaboration, it looks like a tools. These tools like a Google Docs or Microsoft 365, it will be used the distributed computing to enable the real-time collaboration on document. It will be changes made by different users or synchronized and updated in real time. It will be allowing for seamless collaborative work. And next social uses is disaster response and crisis management. This distributed computing playing a critical role in disaster response and crisis management, but providing the necessary infrastructures and tools to be handling the large volumes of data and the large volumes of coordinate resources, and it will make informed decision in real time. Here, the how distributed computing supporting these efforts. The first effort is real-time data processing. This real-time data processing as following the data aggregation, and second one event detection. This data aggregation is nothing but the distributed computing system to aggregate the data from various sources including social media, sensors, and emergency calls. And second one, the event detection. This event detection, the algorithm running on distributed system can be analyzing to incoming data to detect event or detecting natural disasters from social media post or monitoring the sensor data for signing of a fire or flood attack. And the second on the coordinate and communication. This coordinate communication has been following the resource management and the communication network. This resource management, it will helps to managing the coordinating resources by analyzing the data for multiple sources to optimize the allocating personnel, equipment, and supplies. And the next, communication networks. This communication distributed computing, it will support the creation of robust communication networks that remaining operational during the crises. This is includes setting up temporary networks or using existing infrastructures to ensuring that communication channels are reliable and accessible. And the third, disaster response and crisis management following the geographic information system, which means GIS. This GIS as following the mapping and visualization, spatial analysis. This mapping and visualization is nothing but it is used to create and maintain detailed map and visualizations of affected areas. This GIS platform process and visualize geographic data from satellites, drones, and ground surveys, and it will helping responders to understand scale of the disasters and plan their uh, investments. And the geographic information following the spatial analysis. This spatial analysis to assess the impact of disasters, such as analyzing the spread of wildfire or mapping flood zones. And the next one is simulation and modeling disasters management. This simulation and modeling disasters has been following the disaster simulation resource allocations model. This disaster simulation is nothing but it can be running complex simulation to model disaster scenario and predict the outcomes. This simulation to helping to understanding potential impacts and to planning effective response and strategies. And next one is resource allocations models in simulation modeling. This resource allocation model is nothing but it can also model different resource allocations strategies to determine most effective way to deploy resources in response to crises. And next is crowdsourced data and collaboration. This crowdsourced data and collaboration has been following crowdsourced information collaborative platform. This crowdsourced information, the during disasters, crowdsourced data from social media, mobile apps, and other sources can provide valuable real-time information. And the crowdsourced data has been following the collaborative platforms. These collaborative platforms, where the multiple organizations and agencies can sharing the information and coordinate the efforts. This platform facilities real-time collaboratives and decision making. And the next one is scalability and fault tolerance. This scalability and fault tolerance has been following the two categories: scalable infrastructure and fault tolerance. This scalability infrastructure is nothing but it is dynamically to handling the search in data and processing demand during the disaster. And the next, fault tolerance. This fault tolerance is nothing but the fault tolerance meaning that if one part of the system fails, other can take over. This resilience is crucial during crises when maintaining operational continuity is essential. There is notable example for Hurricane Katrina response, COVID-19 pandemic, earthquake early warning system. In COVID-19 pandemic, the pandemic saw the use of distributed computing for the contact tracing, analyze the infection spread, and managing the healthcare resources. That platforms like COVID-19 dashboard provided real-time data and projection to inform public health responses. And the next one is healthcare and medical research. This healthcare and medical research has been following the different field. The first one is biomedical data analysis. So it has following the genomics and the genetics, proteomics and metabolomics. And second one, drug discovery and development. So it has following the molecular simulation, virtual screening, and third one, medical imaging and diagnostics. So it has been following the image processing and AI and machine learning, and electronic health records, and epidemic and pandemic modeling. The first healthcare and medical research field, biomedical data analysis. This biomedical data analysis has been following the genomics and genetics. So the genomics and genetic distributed computing facilities, the analysis of the large scale genomics data, projects like the Human Genome Project involve processing vast amount of genetic information to identify the gene function and variations. And second one, the proteomics and metabolomics is nothing but to analyze the protein structures and the metabolic profile requires substantial computational power. The second one, drug discovery and development. This drug discovery and development has been following the molecular simulation virtual screening. This molecular simulation is nothing but it is used to simulate the molecular interaction and the drug binding process. And the virtual screening is nothing but the distributed system to perform of chemical libraries to identify the potential drug candidates. By running the simulation on multiple servers, researchers can quickly to evaluate the efficiency of thousands of compounds. The third, medical image and diagnosis. This medical imaging and diagnosis has been following the image processing and AI and machine learning. The image processing is nothing but to analyzing large volumes of medical imaging data from modalities like MRI scan, CT scan, and X-rays. And AI and machine learning. The distributed computing support AI and machine learning models that can be analyzing the medical images for pattern recognition and diagnosis. Actually, this model used for can be trained on large data sets to spread across the multiple servers to improving the predictive capabilities. And next one, electronic health records. So it has data integration and data security and privacy. This data integration is nothing but EHR, which means electronic health records. It from a different healthcare provider. This is enable comprehensive view of patient health across various sources to improving continuity of care and enabling better clinical decision making, and data security and privacy of EHR. This electronic health records following the data security and privacy, this distributed computing to ensure the secure and efficient management of sensitive health data using encryption and access controlling mechanism to protect the patient's informations. And next one, epidemic and pandemic modeling. This epidemic and pandemic modeling has been following the two category disease spread modeling, real-time surveillance. This disease spread modeling is nothing but it is used to spread the infectious diseases and predict the outbreak scenarios by processing data from multiple sources such as health reports and mobility patterns. These models to help in planning and response strategies. And real-time surveillance is nothing but the distributed system to aggregate to analyze real-time data on disease incidents from various regions. It will be providing up-to-date information for public health authorities. And next one, clinical trials and research. So personalized medicine. This clinical trials and research has been following the data management and collaboration. And personal medicine has been following the genomic data analysis and predictive analysis, resource optimization, telemedicine. The clinical trials and research has been following the data management. This data management is nothing but the clinical trials generative vast amounts of data from participants, including the clinical measurements and patient reported outcomes. And collaboration. These collaborations, distributed computing supporting researchers across institutions. The researchers can sharing the data, computational researchers to analyzing the tools and to accelerating the pace of discovery and innovations. And next one, personal medicine. This personalized medicine has been following the genomic data analysis, predictive analysis, resource optimization, telemedicine. This genomic data analysis is nothing but it is an individual genetic profile to tailor treatment to specific patient's needs. So this is personalized approach can lead to more effective and targetable therapies. And predictive analytics. This predictive analysis by analyzing the data from diverse sources, distributed computing helps in predicting patient outcomes and personalizing the treatment plans based on the individual risk factor and the health condition. This is the notable example for the human uh, Connect to Me project, Cancer Moonshot Initiative, COVID-19 research. Actually, this Cancer Moonshot Initiative, this initiative uses distributed computing to accelerate cancer research by pooling data from various sources and collaborating across the institution to advance cancer treatment and prevention. And the next one, blockchain and decentralized applications uses in distributed computing. The blockchain and decentralized application having the several significant uses. So several impact field has been following. The first one is trust and transparency. Second one, decentralization. Third one, security. Fourth one, smart contract. Fifth one, scalability and efficiency. Sixth one, data integrity and provenance. Seventh one, disaster recovery. Eighth one, tokenization and incentives. The first we discuss about the trust and transparency. This trust and transparency as following the immutable ledger, auditable transaction. This immutable ledger, the blockchain provides secure and immutable ledger of transactions. Once a data is recorded on the blockchain, it cannot be altered without altering all subsequent blocks and gaining network consensus. and a auditable transaction. This transparency of blockchain allowing all transactions to be auditable, it making it easier to track changes and verify the integrity of data. And second one, decentralization. This decentralization as following elimination of central authority, peer-to-peer networks. This elimination of central authority is nothing but the traditional distributed system often rely on central servers or authorities. The blockchain and eliminate the need for a central authority by distributing control across the network nodes. This is used to reduce the single points of failure and potential bottlenecks. And peer-to-peer networks. These peer-to-peer networks, it enabling the direct interaction between user without intermediates. This is can improve the efficiency and reduce the cost. And third one, security. This security as cryptographic security consensus mechanism. This cryptographic security is nothing but the blockchain uses the cryptographic techniques to secure the data. The transactions are verified using cryptography hashes and smart contracts are executed in a secure environment to minimizing the risk of tampering or fraud. Consent mechanism. Consent mechanism is nothing but it ensures that all nodes agreed on the state of blockchain. This is prevents malicious actors from manipulating the data. And next one, smart contracts. These smart contracts has automated execution, decentralized application. This automated execution, the smart contracts are self-executing contracts with the term of the agreement directly written into the code. The automate process and enforce rules without the need for intermediaries. And decentralized application is nothing but it contract to provide decentralized services. This application can range from financial services to supply chain management, gaming, and etc. And next one, scalability and efficiency. This scalability and efficiency as layer to solution and resource sharing. The layer 2 solution, these techniques such as state channels or side chains are used to enhance the scalability of blockchain network. The solution to handling the transaction of the main chain to reduce the congestion and to improve the performance. And next one, resource sharing. This resource sharing distributed computation, it can be sharing among the peers in a decentralized network, potentially optimizing resources usage and reducing waste. And next one, data integrity and provenance. So it has following the supply chain tracking data provenance. This supply chain tracking, it can be used to track and variety of provenance of good in supply chain to ensuring that each step of the process is recorded and verified. The next one, disaster recovery. It has resilience. This resilience, because the blockchain networks are decentralized, they are more resilient to failure or attacks. The distributed nature means that even if some nodes go offline, the network continues to function. And next, tokenization and incentives. This tokenization and incentives as following the digital assets, incentive structures, challenges and consideration, scalability, regulation, energy consumption. The digital assets is nothing but it enabled to create and management of digital assets or tokens which can be repressed anything from cryptocurrencies and to digital rights or in game items. The incentive structures, the tokens can be used to incentive behavior within the decentralized network, such as rewarding participant for validating transaction or contribution resources. And the challenges and consideration. These challenges and considerations can be following the scalability, regulation, energy consumption. This scalability, although the advancements are being made, scalability remains a challenge for many blockchain systems to ensuring that the networks can handling the large number of transactions efficiently is an ongoing area of research and development. This energy consumptions of challenge and consideration is nothing but some consensus mechanism, particularly proof of work or energy intensive. This is raises concerns about the environmental impact and the sustainability of blockchain technologies. And next one, educational platforms. These educational platforms in distributed computing, it is used for various research and collaboration. The first one, online courses and tutorial. Second one, interactive lab and simulation. Third one, collaborative learning environment. Next, virtual classroom and webinars, research and development platforms, code repository and version control, forums and community support. Here, the first one, online courses and tutorials. The platform, EDX Khan Academy. This is the platform. So, what are the users? The offer structures learning experience on distributed computing concept, including parallel processing, distributed algorithm, cloud computing, and big data technologies. And second one, interactive lab and simulation. This interactive and lab simulation, the platform is Google Cloud Platform Lab, AWS Educate, and Microsoft Learn. Actually, this is used to providing hands-on experience with the cloud environment and the distributed system. Students can experiment with setting up distributed database, managing clusters, and running parallel computation in sandboxed environment. And next one, collaborative learning environment. The platform is Jupyter Notebook Google Colab. It is used to facilitate collaborative project and coding assignment. Students can work on distributed computing problem to sharing the code and receiving the feedback in real time. These Jupyter notebooks and Google Colab, for example, these are used to running code and interactive manner, which can include distributed computing tasks. And next one, virtual classroom and webinar. The platform is Zoom, Microsoft Teams, WebEx. This is used to host lectures, seminars, and question and answer session on distributed computing topics. These tools allow for real-time interaction between instructor and the student to making it easier to explain the complex distributed system concepts. And next one, research and development platform. These research and development platforms, for example, Google Scholar, it is used to access the academic papers, research articles, and publication related distributed computing. This platform to support staying up to date with the latest advancement and research finding in the field. And the next one, code repositories and version control. This code repository and version control platform is GIT Lab Bitbucket. This is used to manage and to sharing the code related to distributed computing project. Actually, this platform used to support collaborative development, version control, and issue tracking, which are crucial for developing and maintaining the distributed system. And next one, forum and community support. Actually, forum and community support, the platform used to challenge related to the distributed computing. This is valuable for troubleshooting and to learning from real world scenarios. Next one, education and software tools. The platform is Apache Hadoop, Apache Spark, Docker. Actually, this platform used to for learning and implementing distributed computing concept. This Apache Hadoop and Sparks are popular for big data processing, while Docker is used for the containerization, which is integral to modern distributed system. And next one, certification and skill development. Actually, this is the platform LinkedIn Learning Cloud Academy platform. This is used to providing the certification and skill assessment in distributed computing technology and cloud services. These certifications are valuable for career advancement and demonstrate proficiency in managing and developing distributed system. Actually, the all the category it will support the aspects of learning to practicing and advancing knowledge in distributed system, it making it easier for students and professional to engage with and excel in this field. And next one, gaming virtual world. This gaming virtual were heavily to rely on distributed computing to deliver the immersive experience and managing the complex environment. So it has following the server architecture and scalability. So it has cloud gaming and game servers. The cloud gaming, the platforms like Google Stadia and Microsoft Xbox. The cloud gaming used for distributed server to stream games to players. This is involved distributing the game processing and rendering the across multiple servers in data centers to handling high performance demand and to reduce the latency. And the game servers, multiple players games often use in distributed servers architecture to managing player interaction, game state, and real-time events. For example, Fortnite and Minecraft use clusters of servers spread across various regions to ensure smooth gameplay and low latency for users worldwide. And next one, data storage and management. It is following the distributed databases and the CDNS, which means content delivery networks. This content delivery networks model to across the multiple servers globally to reduce the latency and to improve the download speeds for players. And next one, real-time communication. These real-time communications as following the networking protocols and voice and chat system. This networking protocols used for communication between players and game servers, and voice and chat system. Voice and text chat system is games often used in distributed servers to handling the communication between players. Next, load balancing and fault tolerance. So it has dynamic scaling redundancy. This dynamic scaling distributed system to enable dynamic scaling of game service based on the player demand. Load balancer distribute incoming connects across multiple servers to prevent any single server from becoming a bottleneck. And next one, artificial intelligence and simulation. So this is going to be following the distributed AI and procedural generation. The distributed AI in a simulation is nothing but it is advanced AI system in games often run on distributed computing platforms to managing complex behavior and simulation. Actually, these techniques such as distributed reinforcement learning and parallel processing enable sophisticated and large scale simulation. And next one, the procedural generation. Games like No Man's Sky use distributed computing to generate vast procedurally generated worlds. So this is involved distributing computation to assets and game elements to across multiple servers. And next one, virtual world metaverses. So this is going to following the precision worlds and the blockchain integration. The precision world is nothing but to sharing environment where users can interact in real time. This is involves managing users' data, interaction, and the world states across distributed servers. And blockchain integration is nothing but some virtual world use blockchain technology to managing virtual assets and transaction. This distributed ledger technology to ensure the secure, transparent ownership and transfer of digital items and currencies within the environment. Next one, content creation and modding. See, this content creation and modding as following the collaborating development concept. Actually, this distributed system to enable collaborative content creation and modeling communities. Such platforms like Stream, Workshop, and it will allow the user to share and to contribute to game modification and content, often using distributed version control system to manage the contribution. The next one, analytic and telemetry. So it has the data collection. This distributed computing system collect to analyze the vast amount of data to generated by players, including game performance matrices, user behavior, and in-game events. Actually, this data is used for to improve the game design and the performance. All the categories it enhances performance, reliability, and usage experience by leveraging distributed resources and technologies. And last one, social impact project. This social impact project in distributed computing increasingly used in variety of global issues through the scalable and the efficient solution. So it has following the climate action and environmental conservation. So it has following climate modeling and simulation concept, environmental monitoring, and second one, public health and disease management. So it has following the epidemic tracking and modeling concept, drug discovery and research topic. And the third one, the disaster response and recovery. It encompasses the disease mapping and coordination, predictive analytics, and fourth one, humanitarian aid and development. It encompassing the optimizing resource allocation, remote education and training, and fifth one, social justice and equity. So it is following the data analysis for social issues and giving technology and e-governance. And sixth one, scientific research and collaboration. So it is following the topics collaborative scientific projects and open research platforms. And seventh one, accessibility and inclusions. It has following the assistive technology, language translation and communications. And eighth one, economic development. So it encompasses the microfinance and the crowdfunding, blockchain for transparency. The first one, climate action and environmental conservation. So it has the climate modeling and the simulation. The distributed computing enabling the analysis of complex climate models to predict the climate changes and assess the environment impacts. The projects like the community earth system model utilize the distributed resources to simulate the climate scenario and to guiding the policy decision. And the environmental monitoring is nothing but the distributed sensor networks and the satellite system collect and analyze the data on deforestation, pollution, and wildlife. For instance, the Global Forest Watch uses distributed computing to process data from satellite and ground sensors to monitor and combat deforestation. And second one, the public health disease management. This public health disease management, as the topic following is epidemic tracking and modeling, drug discovery and research. The epidemic tracking and modeling is nothing but the distributed computing to help the helps in modeling disease spread and tracking outbreaks. The projects like the global epidemic and the mobility model used for distributed system to integrate the data from health report, social media, and mobility patterns to predict and manage disease outbreaks. Drug and discovery research, the platforms such as Folding Home use distributed computing to simulate protein folding and contribute to drug discovery. Actually, the volunteers' computing power is harnessed and advanced research in understanding disease and developing new treatments. Third one, disaster response and recovery. This disaster response and recovery, as the topic is crisis mapping and coordination. Actually, it enables real-time crisis mapping during the disasters. For example, uses crowdsourced data and distributed computing to create and update the maps that aiding in disaster response and resource management. And predictive analytics. This predictive analytics distributed computing is for natural disasters like earthquake and hurricanes. So actually these models use the data from various sources to provide yearly warnings and improve the disasters preparedness. And next one, humanitarian aid and development. Actually the topic covers optimizing resource allocation, remote education training. This optimizing resource allocation is nothing but it is used to managing and allocating resources effectively humanitarian efforts. Systems like humanitarian open street map team utilize the distributed data collection and mapping to enhance to logic and aid the delivery. And next one, remote educational and training. This online educational platforms powered by distributed computing such as uh, Khan Academy and Coursera. It can be providing the educational resources and training to undeserved community, bridging educational gaps globally. And next one is social justice and equity. This social justice and equity, as following the data analytics for social issues topics, is covered giving technology and e-governance. Actually, this data analysis for social issues, large data sets related to the social justice issues such as inequality, like crime rates and demographic trends. The civic technology and e-governance, the distributed support, that platform, uh, for instance, the platform that enable online voting or public feedback collection use distributed computing to manage and analyze the data securely. And next one, scientific research and collaboration. This scientific research and collaborations, as the topic covered, collaborative scientific projects, open research platform. The collaborative research scientific project is nothing but it is the collaborative research efforts across the institution and the countries. It is used to distributed system to analyze the uh, particle physical data. It will be involving researchers in worldwide unified effort and open research platform. These open research platforms, the projects like Open AIRE, it is used to distributed computing to facilitate to sharing of research data and publication to promoting open access and global collaboration in scientific research. And next one, accessibility and inclusion. So this is as following the assistive technologies, language translation and communication. This accessibility and inclusion, the assistive technologies means the distributed computing supporting the development of assistive technology for people with disabilities. This project focused on web accessibility and adaptive technology leverage distributed system to improve inclusivity, which means inclusivity. And next one, language translation and communication for accessibility and inclusion. Actually, the distributed system power language translation services that help bridge communication gaps. Tools like Google Translate use distributed computing to provide real-time translation and support many, etc. And next one, economic and development. This economic and development as following the microfinance and crowdfunding, blockchain for transparenting concept. This microfinance and crowdfunding, it support microfinance and crowdfunding platforms like Kiva, 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 with connected individual organization to providing the financial services to understand communication and economic development and entrepreneurship. And next one, the blockchain transparency. This is used for social impact initiatives to ensure the transparency and the security in charitable donation. It will supply chain management and fair trader practices. Actually, this community providing the infrastructures and capabilities necessary for uh, tackling the complex social issues to enhancing the efficiency, scalability, and reach of social impact projects across the diverse domains. Thank you.
Yeah, thank you so much for your presentation. Yeah, for our
Thank you,
participant,
ma'am.
if you have any question for the speaker, please add them to the chat or you can raise your hand. Yeah, we will wait the question until two, 2 until 3 minutes again. Just a moment. Thank you.
Okay. Hello.
Yeah, we have question from participant in the Zoom chat. Sure.
What question, ma'am?
Yeah, this is from Miss Kinan. How can how can distributed computing be effectively leveraged for social good, particularly in area like disaster response, public health, or education? And what are some real-world examples where this approach has made a significant impact? Thank you.
Actually, this healthcare, uh, it will apply for the biometric data analysis. We covered the genomics and genetics topics. So we will know about the biometric data analysis concepts and medical imaging and diagnosis concept. So electronic health records concept, epidemic and pandemic modeling and clinical trial research, personalized medicine concepts. Actually, the healthcare operation logistics. So all the concepts we will knowing about and managing the distributed community.
Okay, thank you. And then the second question, what are what are the main challenge and ethical consideration in using distributed computing for social in initiative, and how can this be addressed to ensure both effective and fairness? Thank you.
Hello,
Yeah.
can you repeat, ma'am?
What
Yeah.
are what are the main challenge and ethical consideration in using distributed computing for social initiative, and how can this be addressed to ensure both effective and fairness? Thank you.
Thank you, ma'am. So first of all, we We covered all the impacts concepts, social network analysis, crowdsourcing and collaborative projects, the disaster and response and crisis management, healthcare and medical research, and blockchain decentral application, educational platform, gaming in virtual worlds, social impact projects. All the impacts and covered, we will knowing about all the topics. So and we can easily uh, uh, to project the people. Easily we can identify the concepts. The three concepts very important: social network analysis, disaster response and crisis management, and healthcare and medical research. So these three is very important impact in distributed computing. So we knowing about the three concept, so easily we can identify this concept.
Okay, thank you for answering. I think it's very clear answer from Professor. Yeah. Before I close this event, for our participant, please open your camera. I will take a picture on the count of three. Okay, one, two, three. Okay, another one. One, two, three. Okay, smile. Thank you. Thank you for your keen cooperation. Finally,
Thank
we
you.
come to the end of this sitting lecture today. We would like to thank you for Mr.
Karthikeyan.
Kayan.
Karthikeyan.
Okay. And for Professor Noorul for the wonderful information and sharing your knowledge. We hope this information will be beneficial for all participants. At least we hope to have more collaboration in the future with Arunai Engineering College India. The visiting lecture for today and here. We hope to see you soon. Thank you and have a nice
Thank you.
day.
Thank you. Thank you so much.
Goodbye.
Bye. Good night.